आपण मागल्या 3-4 व्हिडिओ लेक्चरमध्ये युनिट बद्दल अभ्यास केला. त्याच्यानंतर कालच्या व्हिडिओमध्ये डायमेन्शन्सचा विचार केला होता. आज आपण विचार करणार आहोत की या डायमेन्शनल अनालिसिसचा उपयोग काय. In the previous videos we have seen what do you mean by the units, what are the derived units and fundamental units. At the same time we have seen how to obtain the dimensions of derived physical quantities. Now the link of the previous videos is given in the description box. It's my humble request to all student and teacher, if you like these videos and if you feel that these are beneficial, then please subscribe and share to your friends. What dimensions are? Dimensions of the physical quantities are the power to which fundamental units are raised to obtain the unit of that quantity. एखाद्या डिराइव्ड फिजिकल क्वांटिटीचं युनिट मिळवण्यासाठी फंडामेंटल क्वांटिटीचं युनिट किती वेळा वापरावं लागतं आणि ते फंडामेंटल डिराइव्ड क्वांटिटीचं युनिट कसं मिळवलं हे माहित करणं म्हणजे डायमेन्शन्स. मग डायमेन्शनचा एवढाच उपयोग आहे का? तर नाही. आपण डायमेन्शनच्या मदतीने अजून काही गोष्टी करू शकतो. त्या काय आहेत त्या आजच्या व्हिडिओमध्ये आपण पाहणार आहोत. In this video we are going to learn what are the uses of dimensional analysis. We will start with the first one. Dimensions are used to verify correctness of physical equation. Dimensions are used to verify whether the given physical equation is correct or not. In other words, we can say that dimensions are used to verify the truth of the given equation. In physics, you might have come across so many equations relating the different physical quantities. अगदी तुम्ही 10वी पर्यंत जरी फिजिक्सचा अभ्यास केला असेल तर तुम्हाला लक्षात येईल त्याच्यामध्ये आपण वेगवेगळ्या फिजिकल क्वांटिटीज मध्ये निर्माण होणारं रिलेशन आणि त्याच्यावरून एक सूत्र मांडत असतो. As an example, while studying Newton's laws of motion, we derived kinematical equations for a moving body along a straight line with constant acceleration. The kinematical equations for a moving body along a straight line are: one is v is equal to u plus at, where v is the final velocity of the moving body, u is the initial velocity of the moving body, a is a constant acceleration with which body is moving, and t time taken to change the velocity from u to v. असं एक इक्वेशन लिहिल्याचं तुम्हाला आठवत असेल. यातला v अंतिम वेग आहे, u हा आरंभीचा वेग आहे, t हा लागलेला वेळ आहे, u पासून v पर्यंत वेलॉसिटी चेंज करताना लागलेला वेळ आहे, आणि a ज्या ऍक्सेलरेशननी हा बदल होतोय ते ऍक्सेलरेशन आहे. ते ऍक्सेलरेशन कॉन्स्टंट आहे असं गृहीत धरलेलं आहे. No, whether the given equation is correct or not, that can be seen dimensionally. How it is seen dimensionally? It's very obvious that whenever we are writing the equation, there are terms in the left hand side and terms to the right hand side. The addition of the similar quantities is possible only. You cannot add a mass quantity with a length. You are not, it is very absurd to say that 10 kilogram of sugar is added to 15 meter of a road. How this addition is possible? But you can do like this one. 10 kilogram of sugar can be added to 15 kilogram of some another material, so that the total mass will become 25 kilogram. Therefore, the similar quantities can be added, and the quantities on the left hand side and quantities on the right hand side are the same. Then we say that the equation is homogeneous. Therefore, dimensional analysis is used to see whether the equation is homogeneous, or it is used to check the homogeneity of the equation. तुम्ही असं म्हणू शकत नाही की 50 सेकंद वेळ ही 10 किलो मध्ये मिसळण्यात आली, तर 10 किलो आणि 50 सेकंद यांची बेरीज होऊ शकत नाही. असं जर झालं तर आपण म्हणतो की ही इक्वेशन होमोजिनियस आहे. असं नाही झालं तर हे इक्वेशन होमोजिनियस नाही आहे. तर 10 किलो आणि 50 सेकंद यांची बेरीज शक्य नाही, म्हणून हे होमोजिनियस नाही आहे. तर इक्वेशन तीच बरोबर आहे जी होमोजिनियस आहे, ज्याच्या लेफ्ट हँड साइडला आणि राईट हँड साइडला सारख्या क्वांटिटीज आहेत. मास कॅन बी ॲडेड टू मास, व्हॉल्यूम कॅन बी ॲडेड टू व्हॉल्यूम, लेंथ कॅन बी ॲडेड टू लेंथ. Mass added to mass will give a mass, length added to length will give a length, volume added to volume will give a volume. This is the homogeneous equation. Whether the equation is homogeneous or not, that can be seen or verified with the help of dimensional analysis. Now we will go here. What V is final velocity. The dimensions of velocity are m0, L1 and t minus 1. How it comes? Because we know that velocity is displacement per unit time. Therefore, unit of velocity is meter per second. Displacement is a length unit. Therefore, its unit is meter. Time is a time. Unit of time is second. Therefore, to obtain the unit of velocity, we have to make unit of length L raised to 1. We have to make unit of time t raised to minus 1. Therefore, dimensions of velocity are m0, L1, t minus 1. This is final velocity and this is initial velocity. Its dimensions are again m1, L1 and t minus 1. And thereafter it comes acceleration. Dimensions of acceleration as we obtained yesterday, it is L1 t minus 2, and here time is that. Therefore, it is t plus 1. And because of this, I will write dimensions on the left hand side of the equation are m0, L1 t minus 1 is equal to, it is again m0, L1 t minus 1 plus one more is there, m0, L1 t minus 2 t plus 1. T minus 2 t plus 1, there is addition of indices in the multiplication. Therefore, it comes out to be equal to m0, L1 and t minus 1. Now, from this equation, what we are able to say here is that to the left hand side there is a velocity, to the right hand side there is a velocity, and this term, though it appears to be a product of acceleration and the time, its dimension will show that again it is a length velocity. And though it is the product of acceleration and time, it is a velocity term. Therefore, the velocity plus velocity term will give a velocity, and the velocity is sum of the two velocities, and it's a very natural, and hence the equation is said to be a homogeneous equation, and this will verify whether the equation is true or not, and this is what we see, the equation is said to be correct if it is dimensionally correct. If equation is dimensionally correct, then we used to say that the equation is homogeneous and it's a true equation. In a similar manner, we will think of one more. The displacement, this is the second dynamical equation. The displacement S is equal to ut plus half at square. Now what S is displacement? Now the unit of displacement is meter. The dimensions of displacement are m0, L1, T0. U is initial velocity. Its dimensions are m1, L1, T minus 1. And here one more T is there. Therefore T plus 1. And limitation of dimension is that with the help of dimensions, we are not able to evaluate the values which are the numbers, or the constants are dimensionless. Therefore, we don't have any dimension for half as it is a number. Then dimensions of acceleration, as we got earlier, it is L1 T minus 2 and T square. Again it is 2 T raised to 2. S म्हणजे डिस्प्लेसमेंट आहे L1, U म्हणजे वेलोसिटी आहे L1 T minus 1, T म्हणजे टाइम आहे, टाइमचा T1. हाफला डायमेन्शन नाही कारण तो कॉन्स्टंट आहे, डायमेन्शनलेस आहे. ॲक्सेलरेशनचे L1 T minus 2 आणि T स्क्वेअरचा T2, and using this what you will see that again here you will write L1 is equal to T minus 1, T plus 1. Again it is L1. Now 0, L1, T minus 2, T plus 2. Again it is L1. Obviously M0 and T0 are there. Here also M0, T0 are there. M0, T0 are there. Therefore what you will see that the length is added. The length quantity is added to a length quantity to obtain a length quantity. Therefore, what the equation we have written on the board is dimensionally correct. The equation S is equal to ut plus half at square is dimensionally correct. Like this, one is able to see whether the given equation is dimensionally correct or not, whether the equation is homogeneous or not, whether the equation is true. That can be studied with the help of dimensional analysis. Then we will go for the second use of dimensional analysis. We know that there are different system of units, CGS system and MKS system. In CGS system, unit of length is centimeter, and in MKS system, unit of length is meter, and we know that 100 centimeter is equal to 1 meter. The conversion factor between the centimeter and meter is 100. In a similar manner, the unit of mass in CGS system is gram, and unit of mass in MKS system is kilogram, and we know that 1000 gram is equal to 1 kilogram. Therefore, the conversion factor is 1000, that is 10 to the power of 3. Now, this is about the conversion factor of the fundamental units. But if one is not knowing the conversion factor for the derived units, then using dimensional analysis, we are able to find out the conversion factor between the unit of same physical quantities in different systems. एखाद्या फिजिकल क्वांटिटीचं, डिराइव्ड फिजिकल क्वांटिटीचं दोन सिस्टीम मध्ये जी दोन युनिट्स आहेत त्या दोघांमध्ये असलेला मल्टिप्लिकेशन फॅक्टर शोधायचं काम डायमेन्शनल अनालिसिसच्या मदतीने करता येऊ शकतो. We will take a simple example of unit of a force. We know that the unit of force in SI system is Newton and unit of force in CGS system is dyne. In SI system, unit of force is Newton. In CGS system, unit of force is dyne. Let 1 Newton equal to x dyne. Here, x is the multiplication factor or conversion factor to convert Newton into dyne. The force is the physical quantity and it has two different units in two systems, dyne in CGS system and Newton in MKS system, and the conversion factor between these two is x. Newton is what? Newton is the unit of force. Therefore, I will write the dimensions of a force m1 L1 T minus 2. These are the dimensions in a SI system. For SI system, I will write here suffix 1. M1, L1, T1. These are the base units in SI system for mass, length and time. And similar to that, I will write x into. I have to write the dimensions of force. Dimensions of force are again m1, L1, T minus 2. How it comes? See in the previous video. Go for the previous video. Link is given in the description. How the dimensions of the force are m1, L1, T minus 2. Now, these are the base units in CGS system. We will write the suffix 2 here. M2 is the base unit of mass in CGS system. L2 is the base unit of length in CGS system. T2 is the base unit of time in CGS system. 2 suffix is for representing the base units in CGS system. From this, I will able to write here what x equal to. X equal to m1, 1, m1, 2. Here L1, 1, L1, 2. T1 minus 2, T2 minus 2. Now, this is what one suffix indicates that it's a base unit of mass in SI system. Here, base unit of length in SI system. Base unit of time in SI system. Here, base unit of mass in CGS system. Base unit of length in CGS system. Base unit of time in CGS system. Therefore, I will write these as base unit of mass in MKS system is kilogram, in CGS system is gram. Base unit of length in SI system is meter, here it is centimeter, here it is base unit of time is second, base unit of time in both the system it is second, therefore t raised to second raised to minus 1, minus 2 and second raised to minus 2. And it comes out to be equal to what 1 kilogram equal to? 1 kilogram is equal to 1000 gram upon gram. What a 1 meter equal to 100 centimeter upon centimeter. Here second raised to minus 2 get cancelled. Here you will get the gram get cancelled, centimeter get cancelled. What remains here is 1000 into 100. What 1000 into 100 is? 1000 into 100 is the value of x finally calculated is 1000 means 10 to the power 3 and 100 is 10 to the power of 2. Therefore, you will get what x is equal to 10 to the power of 5. And hence, the conversion factor that we will get is 10 to the power 5. And finally, we are going to write a result like this. 1 Newton is equal to the value of x is 10 to the power of 5 and there comes a dyne. Therefore, 10 to the power 5 is the conversion factor between the SI unit of force and CGS unit of force. Conversion factor between SI unit of force and CGS unit of force is 10 to the power 5 and hence you will get 1 Newton is equal to 10 to the power of 5 dyne. In this way, the dimensional analysis is used to obtain the conversion factor between the two units of same quantity in different systems. Now, similar to this, we will take one more example. The SI unit of work is Joule. SI unit of work is Joule and CGS unit of work is erg. Then again question arises, how many erg is equal to 1 Joule? And this question can be solved with the help of dimensional analysis. Now let 1 Joule is equal to x erg. SI unit of work is Joule. CGS unit of work is erg. Let 1 Joule equal to x erg. Now, what Joule is? It is unit of work. Dimensions of work are M1, L2, T minus 2. This is in SI system. Is equal to x into dimensions of work. Again, erg is unit of work. It is M1, L2, T minus 2. अरे हे कसं हा जर प्रश्न असेल तर मागले व्हिडिओ पहा तुम्ही. मागल्या व्हिडिओमध्ये आपण प्रत्येक क्वांटिटीचं डायमेन्शन मिळवलेलं आहे. त्यांच्या फॉर्म्युलावरून मिळवलेलं आहे. त्याचा टेब्युलर फॉर्म केलेला आहे. त्याच्यात तुम्हाला हे पाहायला मिळेल आणि त्याची लिंक मी इथे डिस्क्रिप्शन बॉक्स मध्ये दिलेली आहे. आता इथे आपण येऊया. Therefore, what x is equal to? X is equal to m raised to 1 for SI system and here 2 for CGS system divided by m raised to 2 SI system, L raised to 2 SI system, L raised to 2 CGS system, time raised to minus 2 in SI system and time raised to minus 2 in CGS system is equal to, I will write here, the base unit of mass is kilogram. It is 1 so only, raised to 1. Base unit of mass in CGS system, gram. Base unit of length is meter and therefore I write here meter, but power is 2, therefore meter square. Base unit of length in CGS system, 2 suffix indicates that it is CGS system. Base unit of length in CGS system is centimeter and square of the unit, therefore it is centimeter square. And the base unit of time in SI system is second. Here, second raised to minus 2. Base unit of time is second in CGS system. It is also second raised to minus 2. These two get cancelled in the numerator and denominator, and hence you will get x equal to. This is kilogram upon gram. We will convert this kilogram into gram. It is 1000 gram divided by gram. This meter, what meter is equal to? 100 centimeter square divided by centimeter square is equal to. This gram get cancelled. What remains here is 1000. Therefore, it is 1000 into 100 square. 100 is 10 to the power of 2. And square of it is 10 to the power of 4. And therefore, it is 10,000. And hence, the value of x is 10 to the power of 7. And hence, at the last, we are able to write here is that 1 joule is equal to the value of x conversion factor is 10 to the power 7. Therefore, it is 10 to the power of 7 R. This is one more very important conversion factor that we will get from the use of dimensional analysis.